Good morning, everyone. After we finish project management chapter, today we move to the new chapter, forecasting. So what is forecasting? And forecasting, actually, it is the process of predicting what will happen in the future. So it's an essential part of every business. So it's going to impact all the business decisions, no matter it is in manufacturing production or it is for service industry. And for the manufacturing production, the managers need to decide how many shifts they want to run, and in each shift, and how many staff, workforce, personnel, and how the inventory is going to held, and in order to produce the product to meet the customer demand for next month and for the future. So for service business, our textbook give a very good example of Disney World. This is the recreation industry. Obviously, it's a service, and the demand and prediction or forecast will impact the theme parks to organize their employees. Maybe for the holiday season, some more visitors will come to visit. They have more people. They have to prepare more food. So it's going to help them to make the decisions. In forecast, actually, it is both an art and the science of predicting future events. When we say it is a science, because, and for many times, often we use mathematical model, we use the data, try to help us to predict and give us a kind of like an accurate or estimation how many products the demand will be demanded by the customer. When we say it is art, sometimes it's hard to use a model, or it's hard to get the historical data. In this case, the managers need to use subjective prediction, so they need to make the decision based upon their experience or an intuitive thinking. And forecasting, it is a combination of both. When we say, okay, if we use both the kind of like art and science, we use both of experience and mathematical model, it will give the manager a good judgment to predict what will happen in the future. So in terms of time horizon, there are three types of forecast. For short range forecast, so normally it is less than 3 years, and then this type of short range forecast is very common for the restaurants, for the grocery stores, for them to predict how they can schedule their job, to purchasing their supplies, and to hold their inventories, and even to manage their workforce levels. For medium range forecast, I think is very common. You see, it is the forecast will predict what will happen 3 months later. The maximum will be 3 years, within 3 years. And now if you go to some stores on local, you will see Halloween costumes is already on the shelf. And if you go to Sam's Club, and I already see some kind of like Christmas decorations are displayed over there. So this is obviously 3 years, it's 3 months within and 2 3 years. It's a medium range forecast, and it will impact their production planning and a budget, and organize their resources. For long term, it is long range forecast. Normally, it is going to be more than 3 years, maybe 5 years. And quite often, long range forecast is related to new product or new technology development. They are going to arrange the resource for research and development. And this actually, it is very much dependent upon the subject decision of the top managers. And their decision is very critical. If they made a wrong decision, maybe they are going to, put millions of dollars money to research and develop a wrong product, which is not required, not needed by the customer within 3 years or after 3 years. Then that means, okay, the manager will be having a big trouble to lead the company to move forward. There are 7 steps in forecasting. So first of all, we need to decide, what is the usage for the forecasting, for forecast? What is the purpose? Is it for short term or long term? And then you want to decide what are the specific items you want to predict, you want to forecast. And then determine the time horizons of the forecast, because this will decide the historical data you want to gather in the past 2 years, in the past 2 months or 2 weeks. Then the fourth step is to select the mathematical models, so forecast model. And we will spend quite a lot of time in today's class to talk about the forecast models. So that's the mathematical application in this class. Then after you decide the model approach, the next step is to gather the data needed to apply the model. The number 6 is to use the model, make a forecast. The last step, so validate the model and implement the forecast result. After you predict in next month how many parts you want to produce, and accordingly you can arrange your resources, arrange the equipment and the supplies to make the production. So forecast is want to see what will happen in the future. The reality is forecasts are never going to be perfect. Okay, so there always been something unpredictable or randomly issues or factors may impact a forecast model, may impact the data you collected, and therefore impact the result. So most of the techniques, we assume some stability in the system. So there's some kind of like a theme, or behind the model, there is a stable. That's why you can use the past data to forecast the future events. The third kind of like item we want to say is product family or a group of product. The forecast for the group or for the family product are more accurate than individual product forecast. For example, for iPad. So in the market, you see iPad 2, 6 generations last year, and also we see iPad Air, iPad Mini. These are the group of the product, or you call them as a family, product family. So instead of predict or forecast the individual product, iPad Air or iPad Mini. So instead of doing the individual products, we would rather do the whole group, and then you can get a more accurate result than the individual ones. So in terms of forecast approach, And there are two basic approaches. One, it is a qualitative approach. This method will be used when the situation is not really clear. There is little existing data you can use. So if there is a new product, so it's completely new, obviously you have no historic data at all. So you cannot rely on the quantitative data, but in this case, we would rather to use qualitative information to method to make the prediction. So quite often we use intuitions and experience, sometimes use the emotion. Okay, this is what I said. The top managers, if they want to spend the research and the development dollars, the resources to make some like a super product or high technology advanced product, then and the top managers' decision will be very critical. And if they go to the wrong direction, and then it's going to spend a lot of money, but with no result in the end, or little result in the end. And the quantitative methods we use is when the situation is stable. The historical data are available, and you collect a lot of data, and mainly it is used for the existing products or is for the current technology. This part involves mathematical models and mathematical calculations, applications. Everybody can do this, can learn how to use mathematical techniques to forecast the sales and the demand of customers. But I don't think everybody can be able to provide or give a very wise decision based upon their experience. That's why you see the top managers, and they need to have some kind of like a high level of spirit or wisdom to make their decision. But as ordinary people, most of people can learn the mathematical approaches in quantitative analysis. And for overview for qualitative methods, the first qualitative method, it is jury of executive opinions. This, it is, the high level experts. Sometimes they also need to rely on the statistical model, but in the end, they are going to give a kind of like opinion. So it's still a qualitative information, and they may guide some kind of spirit or experience for the statistical model, but basically it's still a subjective opinion in the end. For Delphi method, so there are 3 levels of personnel involved in this method. The decision makers, there are 3 or 5 people. They are the high managers, and they are going to make the make the final decision. But the staff personnel, this is in the middle. What they do is try to contact the customers, gather the information, and distribute the service. So it's a bridge from the managers and the customers. I involved several projects. It's kind of served as a staff personnel. When I was in graduate school, a graduate student group, so 5 or 3 graduate students from industrial engineering, industrial technology, and the College of Business, the MBAs. We did a project for 3M. It's a Minnesota Mine and Manufacturing. This company produced a lot of adhesives and tapes. One time we were given assignment is to collect the sales or kind of like information how the crafters they use adhesives to do their projects. So crafters, maybe it's a lady who did their like art designs, use the adhesives to do scratchbook and make a beautiful like a picture memory books like this. In the middle of the process, they need to use adhesive. They need to use tape or glues. And we help 3M to gather the information. What is the application potential for their glues and adhesives used in scratch or craft in like a section. So another project that we did for 3M was to investigate the glue and adhesive usage for electronics manufacturing production. We all know, we understand chips or electronic chips were produced by, starting with the silicon wafer polishing and thinning process. So in this process, they move the wafer from one station to another station. They need to hold the wafer by using glues or adhesive. Otherwise, maybe the silicon wafer can drop on the ground and then will be broken. So 3M wanted the graduate students and also the undergraduate students in this project to collect information. How much glues and adhesive will be used? What is the production level of chips manufacturing? We use chips manufacturing data to predict glue and adhesive usage. So we sent a lot of emails to the West Coast in New Mexico and in California and asked the managers and salesperson so gather the information. So as a group of graduate students, we served as the staff personnel. For respondents, these are the customer directly use the product. So, and using the Delphi method, that's normally it is a repeating process after several rounds, and the top managers will make the decision. So the third qualitative approach is to gather the information from the individual salesperson and then review their data reasonableness and then make the decision. And the fourth method is conduct the market survey, directly ask the customer. So these are the qualitative methods. For quantitative methods, and we list over here is we listed the information over here. It is so we have these four. So these are, we call it time series. We use the real product data to predict what will happen for the future. For example, if we want to find out the car sales number, and then we want to use the car sales data in the past year, in the past month, to predict what will be the car demand for next month or next year. So the data are all car sales number. And for the phase method is a linear regression we call associative model. This one, we do not really gather the information of the product data. Instead, we use some other associate like a variable and use them to predict what is the product. For example, and I did a project for 3M, and the graduate students, we want to find out a Petri film. And this is a lab accessory. It's a piece of kind of like tape or piece of plastic materials. But on top of this plastic of tape or piece of the material, they have some chemicals can help to identify how many germs, how many bacteria cultured on this Petri film. In the 3M, I mean, 10 years ago or 15 years ago, they had already hold a pretty good, solid market within the US. And they want to sell this Petri film and to internationally or worldwide other companies. So we were asked to find out the potential volume for Petri film, for example, in Thailand, in France, New Zealand, and some other countries around the world. Obviously, we do not have any data about their Petri film usage in these countries because no way you can get this number. So instead of using the direct number, we use some other impacting factors. For example, we gather the information about their food production in these countries or population of these countries because people need to consume foods, all right? And also, how about these countries hygiene regulations? We can, categorize them as a high level of hygiene level, so medium and low. So food hygiene requirement or regulations. And also we can gather the other kind of meat requirements, consuming level in these countries using the associated data to generate a linear regression model to predict the usage of Petri film. So that's exactly the example of linear regression to predict the product volume for the future. And in terms of the time series forecasting, and it is actually a bunch of data, is a set of data. They are evenly collected based upon the time sequence. So it's evenly spaced numerical data observed so at a regular period. So from each of the month you collect the data. And the assumption of time series forecasting is we assume, okay, the future of the data is a function of the past data. So forecast based on the past values, and no other variables will be involved. So whatever the information or whatever the factors impact the past will exactly impact in the future, will continuously impact what will happen in the future. And in the time like a period, you do not see other new variables will be involved in the process. So, and when we look at the time series component, there are generally 4 aspects. One, it is a trend, another is a season, and a random information, and also cyclical information. Here, I think the next picture will give you a better kind of like understanding about the components. What you see over here, obviously the trend of time-wise from first year to the last year, it is growing. It's getting bigger and bigger. And but if you look at the kind of like curve up and down, this is representing some kind of like a periodical information, a repeating trend, and going up and down. So we can call them season, or we can call them as like a cyclical, like a trend, and the demand. So the smaller kind of like jump up and down. This one we call them random variation. Random variation is some kind of like unsystematical information. So, and this picture gives us kind of like a visualization. What do we mean by trend? What do we mean by cycle information or random information? In terms of the seasonal component, for different industries, they treat a season not just as spring and summer, fall and winter. Actually, for different business, they interpret a season as a different period. For example, for restaurants, so their kind of like a season could be like 7 days. During the weekend, they have a high volume of customer, but on Monday or Tuesday, low volume of the customer. I remembered in Cedar Falls here in town, and Texas in Roadhouse. So in like Monday, probably Monday, Tuesday, Wednesday, Thursday, and Friday, there is no lunch. They do not serve lunch, and they only in the weekend. So Saturday and Sunday they serve lunch and dinner. So basically, weekdays only serve dinner. But I went to Texas Roadhouse, this restaurant in Texas. One time it is Monday, I think it is Monday around the noon time. I went over there. They give a kind of like a deal is kids meal is free. It's try to track the customers because they see seasonal or they see like a 7 days up and down pattern. So for like Kohl's or this type of retail store, probably they more kind of like care about seasonal information. What is the spring like spring fashion or fall fashion will be so different from summer and winter. So in the seasonal component, cyclical component I already explained, and this is I think a cyclical component, this mainly talk about the general term up and down, and actually so monthly up and down is also a cyclical component, but here we generally talk about the overall. So you see, it could be like a multiple years duration. We remembered the last economic downturn happened in 2008 and 2009. So from that time to this time, it was about already 10 years. So a lot of business in the in 2008 and 2009, it was in the down kind of like a situation, but gradually they pick up, and then the business generally we see the up and down. And it is impacted by the political reasons, by impacted by economic factors, a lot of other kind of like factors in the big kind of like a cycle component. And we often see some casual or associative relationships, and you can use this to make the judgment about the future forecasting. Random component we have already explained it is erratical and unsystematical, and fluctuation back and forth, up and down. It's a short term and impacting. So it's kind of like a teeth and up and down, small jump. Overall, in the long term, we can really ignore the random impact. Naive approach. This is the first mathematical approach we use. And this one we call it naive because we make a very simple assumption. So assumes the demand in the next period will be exactly same as the demand in the most recent period. So here give the example. The January sales were 68. And then we just use a naive approach. The February sales will be exactly same 68. And sometimes it is cost effective and efficient, but most of the case, you will see, a lot of error or like when you use naive approach, but it can be a good start point. And the second quantitative analysis is moving average. Moving average is a series of mathematical means. When we say it is moving average, we all understand is using several numbers, you add them together and then divide by how many numbers. And when we say moving, is because the average is dropping one and add one, dropping one and add one. So used often for smoothing and provided the overall kind of like impression of the data over time. So if you look at the next kind of like slides, the moving average example. So what happened in sales in like January and February and March. If we use a 3 period of moving range, so when you only get data in January, there's only one data. You cannot calculate a 3 period average. So only in February, there are only 2 you cannot calculate. Until you get a third kind of like a number, now we can predict in April. So it will be the 3 numbers added together divided by 3. So when you, for May, we drop January, but add April, then you get the next kind of like average. So here, I really want you to open the Excel datasheet at eLearning. So go to eLearning. And this is week 4. Here's the in-class 6. I want you to open. All right. Go over here. This is the first example I want you to practice with the moving average. So, so here is, let's see, Donna's garden supply wants a 3 months moving average forecast, including a forecast for next January for shed sales. I don't know what's the sales, but the moving average we just practiced over here is, and you sum of the 3. Okay, divided by 3. Add 3. Oh, here. 3. So this is the 3 month moving average. We answered the first one. The second one is they want to forecast the Donna's garden supply wants to forecast the storage shed sales by weighting the past 3 months with 3, 2, 1 weight on the last month, 2 months ago, and the 3 months ago. in weighted moving average, and we always put a weight, the a bigger weight on the recent data, but less weight in the old data. So this example, you see, weighted average, we wanted to put 3 weight to last, the very recent last. So it's in March, but put weight 2 to February, 2 months ago, but put kind of like 1 weight to the first month, January. And this means we treat the information gathered most recent data will be more like a contribution to the model and more influencing to the model. So using this, we can fill out the rest of the column. So here equals to sum. Oh, this one we use, not use the sum directly, we use, okay, 3 times and plus 2 times plus and divided by 6, because we have totally 3, 2, 1, add them together, it is 6. That's why divided by 6. So, and this is our first in-class practice. The disadvantage we see for moving average is, you know, when you're increasing the n, so that means you include a few numbers to get the average, will make this model less sensitive to change. So, and it does not really predict the trend very well. And also it asks for more historical data. So in this example, we ask for 3 months historical data to get 1 average. The graph of moving average you will see over here is the red one shows, and this is the first example, and just use 3 data added together divided by 3. And the green one is using the weighted average. So this weighted average is better in terms of catching the trend, is making your model more recent, and but overall you see some kind of like a delays in using the moving average. Then the second modeling approach is exponential smoothing. It's still a weighted moving average, but and the width decline exponentially. And also you only use most recent data, and instead of using 3, like 4 or 5 historical data, in this model you only see 1 historical data, which is the most recent data. So, and then we don't have to keep a lot of historical data. And we need to use a smoothing constant value is a coefficient, this alpha. This alpha is ranged from 0 to 1. Well, it is a subjective decision whether you will use 0.1 or 0.5 or 0.9. But if I give you the formula, you will see. So, and this last period this formula, we see new forecast equals to last period of forecast plus the constant value and times the last period actual data, subtract the last period's forecast data. When you see this formula, t minus 1, t minus 1, t minus 1. If you see over here, this is a t. That means your forecast are only going to use the data from the previous period. So if you want to predict the data of October, you only will use the data in previous one, September. So, and FT1, this is a forecast in previous period, and plus this constant ratio and actual number and the actual demand subtract the previous forecast. So here, the example we see, a second example is the predicted demand for Ford Mustang. It was 142 vehicles. That happened in February. But the actual demand that they found out and from the market was 153. Using the smoothing constant alpha 0.2, and then we can calculate the new demand in March. So equals to 142 plus 0.2 and times 153. This one, it is actually demand, and subtract, this is the previous is the forecast, here is the previous forecast, and then we can get the real demand equals to 144. So this is my second in-class work in Excel. So actually, I did this pretty much already. So what I want you to do, and it is a forecast in March, for March. And this one equals to the calculation of equals to previous demand, previous forecast 142, and plus the exponential and times and 153, that's the actual demand, subtract 142. Here is forecast demand, so equals to 144.2. So basically repeat this. Why repeat? It can help you to understand the formula better, what I'm saying over here. And the next one, after we generate a model, for example, we can generate a naive model or moving average model and weighted moving average model. And also we can generate an exponential smoothing model. All these models, how good they are, how accurate of the model can describe the prediction, we need to use a term to measure the precision or accuracy of this model. So the first term or measurement we want to use, it is mean absolute deviation. So mean absolute deviation equals to the actual demand and subtract the forecast result. And it uses this, make sure it is an absolute value. We only use positive. Otherwise, your negative and the positive will be canceled out, and will lose the purpose of we doing this measurement of errors. So absolute deviation. So this is one kind of like a measure of the modeling errors. So what do we do? The example, we still use the second example, using the example, and so first of all, we try to get the forecast result using the alpha equals 2.1. And we want to compare how about the compare the two models when you use alpha equals 2.1 or alpha equals 2.5 to see which model will give you a better kind of like a predicting result. So mean absolute deviation, when we do the calculation, go to the Excel. So this is in class 3. Now, so when you do the forecast, this one equals to the forecast 175 plus and 0.1 and times and actual value and subtract and the forecast value. So here we get these are all the kind of like a forecast. And if we change the constant number, so 175, this one, it is a given. And say this is during the 8 quarters, the port of Baltimore has uploaded large quantities of grain from ships. The port's operation managers wanted to test the use of exponential smoothing to see how well the technique works in predicting the tonnage unloaded. So he guessed the forecast of grain unloaded in the first quarter was 175, which is this one. It is 175. It's a forecast, it's a guess. So, and use this plus 0.5 times and this one subtract the forecast. All right, now we finish the first one. We use alpha equals 2.1, alpha equals 2.5. So the next one, we want to find out the forecasting error. How about the absolute deviation? So you can copy this one, Control C, and copy here. And then absolute value, so ABS, subtract 175. Since its absolute value is always a positive number. And then we can find out what is the sum of the absolute deviations. Right. And then the mean absolute deviation. So this one we can say it is average. And then you calculate the average equals to divided by 2. Oh, not divided by 2, divided by 8. And similarly, we can copy and paste this column. When alpha equals to 5, the forecast is over here. Oh, okay. Now I want you to redo this. How about copy? Paste special. So just paste the values. Then your absolute deviation equals to ABS of 180 subtract 175. So this one I want to use not change the number to be format as a number. So that's all. And then we can do the sum of all the absolute deviations divided by sum. Change this to be format as number. Then equals to average equals to this divided by 8. So this one is wrong. So copy and paste special. So this is my result. All right. Go to here. Oh, this one. So this calculation we found out mean absolute deviation, which is corresponding to this slide. Mean absolute deviation. And then the next one we want to find out it is common measure. Next one we want to find out is mean squared error. So mean square error is for, we want to just find out the errors and make them as a square, and then you add them all the squares divided by n. So for this one, I want to use this and a square. Okay. And then you put this as a formula. They all as a square. So it is an error square. And this one, it is the sum of the error squares. And then divided by 8. And similarly, you want to do the error square for alpha equals to 0.5. So square sum of all of the squares. And it equals to here divided by 8. All right. So in this, a second measure, this error is mean square error. So we did this calculations, and so which is 190, and for the alpha equals to 0.1. So it is exactly the result we see from Excel. The last error is the mean absolute percentage error. So how you did this one? If you look at this formula, it's quite a kind of like awkward or long, or how do you understand this formula? So you use this one is absolute percentage error. Is a percentage error. So we get this 5. So this is absolute error. You divide by the divided by the actual number. And then convert this to be 100. Equals this. 100 times this one, and then divided by so it's 2.78%. So if I turn this as a percentage value, this already turned this as a percentage value. So now you see, if you see, you get is how about if you do not, put this 100 over here and just put use the fraction format. So but if I change this as a format this as a percentage, 2 decimal points, you see probably this will be better because they said it's absolute percentage error. Now you see percentage give you a very obvious kind of like a visualization. Here it is all the errors are in terms of a percentage value. So if you do sum, and now we can have the average. So put the also as a percentage format. And we will do the same thing over here. Absolute deviation divided by the actual tonnage. And make this as a percentage value and 2 decimal points. And then the sum. Here percentage value, 2 decimal point, and then this one it is it is average divided by 8. So make this as a percent. So these I highlighted this, and this is mean or average absolute deviation. This is the mean error square. So it is mean absolute percent. These are the real measurement of this model. So from this, we see, okay, if you use the constant value alpha equals to 0.1, this model is better than alpha equals to 0.5 because the error is smaller. So this error is smaller than 195. And here is percentage error wise, 5.59% is smaller than 6.76. So here it is the in-class practice. And so I probably want to stop over here. I will give you some summarizations next time. And today's in-class practice, I want you to try by yourself and fill out this sheet 61, 62, 63, and highlight these numbers you figured out and submit it to e-learning.